Hello students, let us understand about the Wittig's reaction today. This reaction is particularly used for synthesis of substituted alkenes with the help of aldehydes or ketones in presence of violates. The violates which we are using here is phosphorus violet. Violet is basically a molecule that bears no overall charge, but it has a negatively charged carbon atom which is bonded to a positively charged heteroatom like phosphorus in this case. Phosphorus violates are represented in two forms. So, one of the form is this and the other form is this. What you can observe in the first form, that is a double bond between carbon and phosphorus, and in the second form there is a single bond between carbon negatively charged and phosphorus positively charged. Right? Now, let us move on the reactions involved. So, see the first general reaction. If I am taking any carbonyl compound, this carbonyl compound, suppose I am interacting with this particular phosphorus violet, how is the reaction going to proceed? Triphenyl phosphine oxide from here, it will be released as a byproduct, and what you are left with is, then this double bond O will be substituted by double bond CH2. So, this CH2 comes from here, from the violet. Is it simple? So, that is a simple reaction whereby double bond O you have to replace with the half portion of the violet which you are using, right. So, you need to select a suitable phosphorus violet and a suitable carbonyl compound depending on what kind of product or what kind of substituted alkene you need to prepare, right. Consider the second example. In the second example again, this is the other portion of the violet. So, what is going to happen? This double bond O will be replaced by double bond CH3. So, that is your substituted alkene. Now, when I say there is a formation of substituted alkene within this reaction, there is possibility of having geometrical isomers. Cis and trans isomers you can say, or E and Z isomers, right. Now, this isomers whenever are possible for a particular alkene within the reaction, always remember that your trans isomer will predominate within the reaction. Trans isomers means E isomer will always predominate. Now, let us consider this same concept, this alkene which is formed, right. In this alkene, this is a disubstituted alkene. See here, what you have to do, how you are going to find out which is a Z isomer and which is an E isomer. Just imagine a line passing this way, okay. Now, check the priorities of the substituents attached. So, on the left hand side, this is of the higher priority, and on the right hand side, CH3 is of the higher priority, right. So, both the higher priority substituents are on the same side of the double bond. So, this is a cis isomer which is also called as a Z isomer. Now, consider the other part. Again, imagine a line dividing the molecule this way. Check the priorities. So, this is the higher priority on this side, this is the higher priority on this side. Both the higher priority substituents are opposite to each other, anti to each other. So, this will be called as a trans isomer, that is a E isomer, right. So, if you are clear about this, let us move ahead. Now, let us consider this example whereby, say I want to prepare styrene. So, this right hand portion, the product is styrene. Say I want to prepare styrene from benzaldehyde. Then the violet I have to select, which type of phosphorus violet I will be using. So, you have to check the molecular formula of styrene and that of benzaldehyde. What is the difference? Instead of double bond O here, I want double bond CH2. So, simply what you are going to do, you will take that phosphorus violet which is having CH2 group in it. Clear? So, simply I will be working out for this. So, I will be taking benzaldehyde, I am taking this particular phosphorus violet and I will directly get my required product, that is styrene. Clear? So, I suppose whatever the reaction comes to you in your papers, whatever the reactants they are providing to you, whatever the phosphorus violets they are giving to you, or whatever the product they are expecting from you, you will be able to cope up with the reaction and you will be able to work out for it, right. Now, let us move on the mechanism. See the mechanism. In this case, we are taking in the first step your phosphorus violet, right. Now, this phosphorus violet is interacting with the carbonyl compound, right. So, what is happening here? See, in the case of phosphorus violet, there is a negative charge on the carbon atom, means this violet is acting as a strong nucleophile, and so this nucleophile will attack the carbonyl group. How it's going to attack, or why it is going to attack? Because in case of carbonyl group, oxygen will be having a negative charge, carbon will be having a positive charge. So this carbon negative density will attack on this carbon which is having a positive density, right? Resulting in the formation of this intermediate product which is highly unstable, and it is called as betaine. Now this betaine being unstable in nature and having clear separations of positive and negative charges, it will immediately convert into a 4-membered cyclic intermediate called as oxaphosphetane. Okay, how the conversion to oxaphosphetane is going to take place? That is due to the negative charge density on oxygen atom. So this will move towards phosphorus. There will be a bond formation taking place between phosphorus and oxygen. So there is a 4-membered cyclic ring intermediate formed which is called as oxaphosphetane, right? Now this particular cyclic intermediate then subsequently decomposes into substituted alkene and triphenyl phosphine oxide. Now what is the driving force for this reaction? Why the conversion into triphenyl phosphine oxide or substituted alkene? The only reason for this is a formation of a strong phosphorus oxygen bonds which take place during this particular decomposition at the expense of the weak carbon phosphorus bond, right? So this carbon phosphorus bonds and electrons move towards here. As a result, there is an increase of the valency at the oxygen atom, and this bonding electrons now will move this side, because of which the bonds will break here and here, right? At the same time, there will be a double bond formation between phosphorus and oxygen, resulting in the formation of triphenyl phosphine oxide and the substituted alkene. Clear? So that is about the Wittig's reaction. Now let us see the question related to this particular reaction. So the question is, betaine is an intermediate in, options are given to you, Robinson annulation, Wittig's reaction, Wolff-Kishner reaction, or it is Birch reduction. So betaine is an cyclic intermediate or a precursor to a cyclic intermediate produced within a Wittig's reaction, right? So the answer is option number C. Okay. So such type of questions can appear within your entrance exams. Be prepared for it. That's for today. Work hard. Stay safe. Okay.